Okay, this video is going to be on one of the most confusing things that specialist students find, and that is in vector resolutes. And we've already talked about resolving vectors into components, and it's a good place to start. And let's say we've got vector A like that. What did we do? To resolve vector A, we wanted to change it into rectangular components, in other words, perpendicular components. What we did is we just changed colours. We changed it into a horizontal component here. So just to say, let's call it A horizontal, something like that. And then we changed it into, and we had a vertical component here. Okay, so we broke that up into two pieces. We broke A up into a horizontal component and a vertical component. And the reason we did that is it's easy to think about a vector or a force when we can think of it only in the horizontal direction. What is this vector doing in the horizontal direction? What is it doing in the vertical direction? It's easier to think about. It's easier to add vectors together when they're in these forms because we can just think about it in its pieces. And so that's what vector resolutes are doing also. We're resolving vectors, but this is a little bit more difficult. Here, what we're doing is we're resolving A into horizontal and vertical components. Now I'm going to confuse you. What we're going to do now is something a bit different. We've got some vector A, and then we've got some vector B. Now what we're going to do is we're going to resolving A into, now we're not going to resolve it into horizontal and vertical components, but we are going to resolve them into rectangular components. But what we want now is not horizontal and vertical. What we want is in terms of B. What we want to see is what is the component of A that is, let's try to draw it along here without messing everything up. That's a bit messy, sorry. There is a little piece of A here that is, and I'll just write, so that's the piece of A that is parallel to B, okay? A little piece of A that's parallel to B. That's the chunk there that's parallel to B. And also, so that's like this horizontal part here. There's this piece here. This vector that's part of that. And there's also another part that's here. And we have this other part, and that's perpendicular there. So we've got two components there. We've got the piece of A that's perpendicular to B. We've got that piece there. So basically what we're talking about is here we've got two components of A that are horizontal and vertical. Okay? Here it's just a bit more complicated, but it's essentially the same thing. If you got this, if B was just a line that was horizontal, it would be exactly the same as this. But here we're giving a situation where we can talk about any vector B, and it's really important when we've got forces that are on planes, on different angles and that sort of thing. It means that we can talk about more complicated vectors, and it's a really important thing to understand. So let me say it again. We've got our vector A. The component of A that is parallel to B is this red vector here. That's the part of A that's parallel to B. And then here in the green we have the part of A, the resolute of A, that's perpendicular to B. So we've broken up A into two pieces, one that's parallel to B, one that's perpendicular to B. Hope you understand that. If not, I'll go through it again in class. It's really important. Let me give you the formulas. Okay, so here we go. So you have A and you have B. Okay, and I'll just quickly do it again to make sure. So, I swear I chose red. and you have this here, which is like your parallel component. And I might just keep it like that. Okay, so I'll say, and what we call it, okay, so what we'll say is the vector resolute of A parallel to B. Okay, so that's this red part here. It's the vector resolute. It's the part, the component of A which is parallel to B. The formula for that is, and there's a couple of different ways you can do it. The way I prefer is to have A dot B over B dot B all multiplied by B, and I'll prove this in class. No need to go through it now because it's a bit lengthy. A dot B over B dot B times B. That's the formula for that. The other formula, which you'll see used a lot in solutions and everything, I find this really clumsy, but it is actually good to have written down just in case it is faster. But it's A dot B hat multiplied by B hat. The reason I don't like it is because B hat, you get fractions and that sort of thing. Because you're dividing by the magnitude of B, it gets really messy. So this is much cleaner. You get a nice fraction easier instead of this sort of cancels out fractions and then it's messy. But anyway, so that's the vector resolute of A. That will give you this vector here, that part there in red. So that's that. That's as easy as that. Our second piece of the puzzle is this part here. Okay, and so I'll do it. And what this one is called is the vector resolute. See if you can guess what this one will be called. The vector resolute of A, because it's still, we're breaking up A into its pieces. Vector resolute of A perpendicular to B. That's what that's called. And the formula for that is simply A minus, so the vector A, and if you think about this, you'll see why this is the case. A minus this vector resolute here. So what I'm just going to do is put it back in red. So A minus A dot B over B dot B. Okay, so it's simply A minus the vector resolute of A parallel to B. Okay, so that's just exactly what's up here. And they're the two formulas that you need. Believe it or not, in last year's exam, doing just this was worth 5 marks. It was unbelievable. If you know how to do this and you understand it, it was 5 easy marks. And so that's that. I might just write down the scalar resolute. I'll show you this in class anyway, but scalar resolute of A in the direction of B is simply A dot B hat. I'll just write that down there, A dot B hat, and that's just this piece here. It just tells you what fraction, how much it gets scaled up by. Okay, so let's just do a quick example of this, and it's, if you know how to do it, really simple. Okay, so a quick example. I'll say express A as vector resolutes in direction of B, being a bit quick. I'm just going to sort of just change this a little bit. Express A as vector resolutes. I'll just write it, sorry, I'm just as the sum, okay? As the sum of vector resolutes. Express A as the sum of vector resolutes in the direction of B and perpendicular to B. A bit sloppy, but there you go. And I'm just going to make something up. Hopefully it doesn't get too horrible. A being equal to I minus J plus 2K, and B being equal to 2I plus J. Okay, So there's my two vectors. Let's go. So firstly, I'll just break it up. So firstly, parallel. We want A in the direction of B, and so the formula for that is A dot B over B, you get used to this, B dot B, all multiplied by B. Okay, so that's equal to, what's A dot B? 1 times 2 is 2. Negative 1 times positive 1 is negative 1. 2 times 0 is 0. So just 0 on there. What's B dot B? That's times by itself. So 2 times 2 is 4. 1 times 1 is 1. And so that is our B dot B, and it's plus 0 as well because there's no K there. And the vector B, we just write down here as 2I plus J. There's our B. Okay, does this work out nicely? Let's have a look. 2 minus 1 is 1. 4 plus that, so that's 1/5. 1/5 of 2I plus J. And so we can leave it like that if you want, or you could write it as 2/5 I plus 1/5 J, something like that. But there is your parallel. That is already 2 marks in last year's exam. Unbelievably easy. Okay, so there's your parallel vector. Perpendicular vector. Perpendicular vector is A minus this. Remember, that's the formula, A minus the parallel vector. So it'll be A minus 1/5 2I plus J. I might run out of space, I hope not. Equals, let's just write A, I minus J plus 2K. Okay, now I'm going to just write this in expanded. So minus 2/5 I minus 1/5 J. Okay, and we'll just neaten this up a little bit. I'm going to run out of space. Okay, we've got I minus 2/5 I, and so we'll get 3/5 I. What do we got? J's? We've got negative J and we've got negative 1/5 J, so we'll end up with negative 6/5 J, and we've got positive 2K. That remains. And so there is your perpendicular vector. There's another 2 marks in last year's exam. Really, really easy. Now the question asks, express A as the sum of vector resolutes in the direction of B and perpendicular to B. So the sum of, so therefore what this means is that we can write A as the sum of this vector plus this vector here. So it's equal to 1/5 2I plus J plus, I'll just put it in brackets so that's all, you can see what's happening, minus 6/5 J plus 2K. Sorry about I've messed it in there, but there, this is how you'd need to write it. And that was the only tricky thing about the last year's exam question, is that you have to write A as the sum of 2 vector resolutes. And this is what we were talking about before, is that we've got 2 vectors. We have now written A as the sum of its parallel to B component and its perpendicular to B component here. And what that would quickly look like is if you've got A and B, that you've just simply drawn this one here is this, it's parallel to B, and this one here is this part here, that's that vector there. And you can see that green plus blue equals A, which is exactly there. Hope you understand this. I'll go through this again in class, but that is the guts of vector resolutes.